Hello everyone and welcome to the first episode of Machine Learning with R, a really fantastic journey. I'm Hamidreza Bolhasani, PhD of Computer Engineering, researcher, chief data scientist and founder of DataBioX. I'm really happy to see you again in this video series and I hope that it would be useful and informative for you. Okay, so let's quickly start. What is machine learning? I know that all of you and all of us already knows what is machine learning. Just as a quick review, AI, artificial intelligence, that has revolutionized our life in many aspects, has a leading subtype named machine learning. According to Arthur Samuel definition on 1959, ML or machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. It's very important. In traditional programming, we had some rules and also some data, so it would lead to some answer. But in machine learning, we have some data and we have some answers, and it will give us some rule. And so in machine learning and deep learning we wanna find some patterns, we want to find some rules. Because there are lots of references and you can find them, but here you can quickly and you can briefly see what are the main methods and algorithms in machine learning. We can start with the first one, regression, but during this course I will also introduce you some good references for your study. Okay, and also in the near future I will produce this course with Python. Okay, so one of the very old methods is regression. As you can see, we have some data and we want to find a relation between them and find some rules. As I told to you, we have some data and we have some answers or label and we want to find some rule. Okay, so let's start. Okay, since the subject of this episode is regression, one of the most fundamental concepts in machine learning, we should review some basic concepts. As you know, machine learning is not something very different from math. It's a combination of mathematics, statistics, probability, and also linear algebra. So it's a combination of some sciences that is applicable, that is used with computer science for the applications and for the things that you can see today. Okay, so first of all we should define variance, covariance. First of all, let's define variance. Variance gives information of a single variable. Please note that it's related to a single variable and it's a formula. We can see as to the power of 2, and here it is the observed data and it is the mean of average mean of all data. Okay, and n, the number of all data. We can see here. But covariance gives information on the degree to which two variables vary together. It's related to two variables, how x and y vary together. For example, when x goes up and as a consequence y goes up, covariance of x and y is positive. Okay, and when x goes down and y goes up, covariance of x and y is negative. And when no constant relationship between x and y, so the covariance of x and y is 0. Here we have an example. You see in the left side we have a high variance data. You can see, you see, yeah, so we see that the covariance is very high. Yeah. And here we have low variance data, and we can see the covariance is low here. So let's see what's the meaning of correlation and regression. Okay, correlation. Is there any relationship between two variables x and y? Is the meaning of correlation. In correlation, we are seeking for relationship between two variables x and y. X is independent. X is independent or explanatory, and y is dependent, response. So we should also note that correlation is not equal to causation. So x is independent and y is dependent. So we can observe, we can change or do something on x and observe y, because it is the response. So this is the formula for correlation. You can see here, and we already defined the S in the previous slide. Yeah. And regression. So what is the regression? How will a certain independent variable predict dependent variable? How x can depend y? How this independent variable predict dependent variable? For example, this is the we will cover some examples in the following, but for example, here is the square meters of house, and this is the price. It is the square meter of the house, and it is the price. So it should be a relationship between these two parameters, and correlation wants to find what's the relation between these two variables. Okay, here we have some examples and with scatter diagrams. See, we have 4 cases here. In some case we have a strong negative relation. You can see with increase of x we have decrease of y. You can see we have decrease of y. So it is a strong negative relation. In some situations we have a strongly positive correlation. You can see with increase of x the y values are increasing. Yes. Yeah, and we can see the r value here is negative, here is positive. This is positive correlation. It shows that, it says us that when x goes up, y goes up. Here when x goes up, y goes down. Here is weak positive. Here is weak positive correlation. We can see. Yeah. Also the pattern shows us in comparison with this. Here also the value of r shows us this is weaker than this. The correlation between x and y is very clear in the photo, and in some cases we have nonlinear correlation that you can see the r is something like near zero, and it's almost harder to find. But in first lessons and concepts for learning machine learning and regression, we start from these easier cases. For example, let's have a good example here. We want to find the relation and correlation between smoking in the people and lung capacity. So reasonably and logically, we think that if we smoke more, so the lung capacity would be less, and the data also say us this meaning. Yeah, we can see these are the cigarettes. Yeah, and we can see as well as the cigarettes number become higher, so the lung capacity become less. So they have we can find that easily. They have a negative correlation. Yeah, like this negative correlation. So let's see, are we right or not? Yeah, yes, we are right. You can see there is a strong negative correlation. We can see that if the smoking years in people become more, so the lung capacity become less. Yeah, so there is a negative relationship. The correlation is negative. If smoking years become up, the lung capacity become down, and the R value also shows us this. Yeah, so in this episode we want to see an example in R and solve it. A very simple example that you can do with me, hands-on experience, and no need to share the code because it's very easy to repeat. Okay, and see what can we do. Okay, before that, so our purpose is to find relationship between, as I told to you, this is x, and we wanna find its effect on y. So we are in linear problems, we are seeking for this formula. Very simple. This is very simple problem. We just need two parameter here: a slope of this diagram, and intercept. Okay, so the process of predicting variable y using variable x, finding this like red plot, and tell us how values in y changes as a function of change in value x, and calculate the best fit line for a certain of data. Here you can see some green dots. These are the true values. And we wanna fit a line here to find a rule based on this data. So we fit this line based on regression, based on this method, and this is the predicted value y prime. This is the, or y hat. This is the predicted value. We all knows that the predicted value has some errors like this. Yeah, you can see the distance to the actual to the observed value with the predicted one have some errors. Okay, and it can be calculated, that we will show later. So let's see a very good and very simple example. And because of this, I really love R, because it's very handy. It's very very nice and lovely to do very fast things, and it's really result oriented. So let's start. Here you remember from the previous episodes we already talked a lot about ggplot2, a very strong tools in R for visualization. If you don't remember, you can have a look at my previous episodes regarding data visualization in R. And here we have an empty cars, a built-in data set about the car specifications, some car specifications in R. We have some built-in data sets in R that is used for like this training and some tests. Okay, I remember here we say that the X value WT here is the weight of car, yes, and Y is mile per gallon. Okay, we want to see what's the relationship between the weight of the cars and the power constant, the energy consumption, the miles per gallon. How is the relationship between these two parameters? So let's first plot this and discuss about it. Okay, first of all, we wanna ggplot2, yes, and control enter. Yeah, already imported, and we have this data set. Yeah, you can see here. Yeah, this is the data set. You see the name of some cars and some specifications like cylinders, and we just here want to check the weight and mile per gallon. Okay, so here we want to plot diagram data equal to empty cars, then AES statistic, X equal to WT and Y MPG, and then geom underline point. Yeah, so let's see. Yeah, as we expected here, yes, we expect this, but we can also find from the diagram, as the weight is increasing, the mile per gallon is decreasing. Yeah, so this is for example, a line that I have fit like what we learn in regression here, and our purpose is to find this line and predict the value and the data that we don't have and it is the basic and it is the fundamental of machine learning, because it covers some data that we don't have. So it you can see that it is the base of AI, because AI give us some information about the things that are not there, or so you can see that why in all the AI courses it's recommended to start from the very basic concepts of machine learning. And I think the very basic concepts of machine learning is also this one, regression, and some things that we very quickly have described here. So let's fit this line with R. How we can fit the code on just this is the same, but here we have the geom smooth, and the method is linear model, and also SE equal to false. SE is a method here. SE means what? We can see here is ggplot2 documentation, and SE we can see what is SE. Yeah, SE the confidence interval. Okay, confidence interval. So let's see what we can do. So again, copy this and geom, yeah, method equal to lm. But first, before set se to false, let's see what's the result. Yeah, we see that the confidence interval here, the confidence interval, but we don't want it now, so se equal to false. Yeah, so we see this line that it was our purpose. The first thing that we want to do, for example, we want to predict if the weight of a machine, a car, is here, that we don't have in our observed data. What's the predicted mile per gallon value? We can find it. So how we can find the formula to find these two important parameters, intercept and slope? As you can see, we can find a formula for it if these two parameters are like this. So we want to check the effect of x on y. So y equal to ax plus b. So here y is a mile per gallon, mpg equal to a x here is weight and b means intercept. So mpg here is minus 5.3 wt plus 37. Yeah, so for any wt, for any weight, you can predict mile per gallon. So how we can find this intercept and slope? Just this linear model data equal to empty cars mile per gallon based on weight. Let's see. Yeah, we can see this, the coefficients and intercept is this, and this is the coefficient of wt that I already shared with you. Yeah, this is the coefficient of wt and it is the intercept. Okay, I hope that it was useful and informative for you. In case of any questions and any idea or comment, please feel free to contact me, and hope see you in the next videos. Bye.